have supervised learning, in which we have the decision tree. And we have seen the introductory part of the decision tree. And today we will see what is mean by the building a decision tree, and that is a necessary step. And how we can use such step, and where we can use a step, that is important aspect. We need to take care of all these points. So in the lecture number 6, what we have observed, we have seen the introduction to decision tree with some examples. We have seen the different example by which we have seen what we mean by the decision tree and how we can understand decision tree followed by the decision tree with the regression and decision tree with the classification. We have also covered the advantage part, disadvantages part. From this point, we can say where we can use the decision tree. So what is the beauty of the decision tree we have seen with the some introductory part. If you don't have any doubt, then we can start this point here as a quick review part. That is from the previous class. We can say that the question we had seen into the our previous lecture. That was what is a decision tree? As we know, decision tree basically a tree shaped supervised learning method in which we need to predict the output. See, whenever we need to predict something based on the our regression approach, then what we are following? We are following the decision tree followed by the regression. But the point you need to keep in mind, the classification and regression, or we can say these are the two important approach for the machine learning. In the regression, the purpose of the regression or the aim of the regression is to determine the prediction of the some value based on the independent variable. It could be more than one. But when talking about the classification, so the purpose of classification is saying to us, you can classify your data based on your some input. So what is the value by which you can define that is known as a logic? Where truly speaking, based on your logic, and based on the logic, you can distinguish your information or you can filter your information based on the Boolean values. The Boolean values can be identified whether true, false, 0, 1, or yes or no. So that is the point we need to keep in mind. So when talking about the decision tree in Python programming, especially, so the purpose of the Python programming, especially used for the decision tree, to solve the both kind of problems, that is the classification and regression. And from this point, we need to understand an example as a review purpose. See, this is the example. Here, what I have observed over here, what you can see here, there are a group of the animals we have over here. So color is equal to yellow. If color is equal to yellow, then what I'm doing over here, I'm just filtering my information based on the color features or color parameters. So I'm distinguishing my information based on the true. If it is true, it means animal is belong to the following the color yellow. So they can be categorized over here, else they can move to the non-yellow color part. So it is found over here. The Java and tigers belong to the yellow color, so they have been classified here. They have been classified over here. Please listen carefully. But those animals who are not following the color yellow or they're not having the color yellow, so they were considered into the non-yellow category. So we have the here some animals, those are the monkey and we have the elephant. From this point, you can easily understand some other aspect by which you can simply say the if height of the animals is equal to 10, so definitely as we know, this is our condition on which we are defining something. What we are defining? We are defining a new condition on which we can filter our information, because in the group of the animals which belong to the yellow color, we have the different kinds of animals, so we can classify our information based on our data. So here we have the subdata, where truly speaking, or that is also known as the some subset of the our data, we can say. So here we found that Java is equal to the height of 10 or more than height 10, so 10 feet. So we can get it classified over here. So Java is into the other part, and here the rest of the part belong to the tiger, so they will be considered to the other group. So overall, if you're looking at the same label, the height of the animal is less than 10. So definitely the monkey is a non-yellow color animal, and he or the monkey does not belong to the height of greater than 10. So we consider that animal into the here. So we need to see our condition. What is the condition? Height is less than 10, and it consider if true, then the monkey will be chosen as a part. Else we can say move to the false part, so we can found the element will be that part. So overall what we are doing, we are filtering, we are classifying our information. So this is a good example of the classification followed by the decision tree, and that is my point. From this point, I can say or I can ask any questions, but before that, just let me know. Do you have any problem here?
No, sir.
So this is the introductory part. We have to detail. So here you have went out, then you can ask me. And this was the revised part, we can say. No doubt. Now, shall I move to the next slide?
Yes, sir.
Okay, good. In this slide, I have written nothing. Why? Because I have an idea by which I can distinguish the decision tree with regression and classification. These are the two important terms we have. So by using the mouse pointer, I can write over here something to clarify the point by which you can understand. We are understanding the decision tree with regression and classification. If I'm using the regression followed by the decision tree, so the point we need to keep in mind in proper way, that is, you can say. First, I'm just using the right now regression and I'm explaining decision tree with the regression. And there's some points I need to keep in mind and we need to keep in mind to understand the concept. If you're talking about the regression, so what point we need to keep in mind? First point, that is the point. We have the two parameters. One is a dependent variable, and another one is independent variable. Okay, it doesn't mean right now we are having decision tree. Just keep in mind we have the regression. So we have the dependent variable, and other one is an independent variable. Okay, that is the point we need to keep in mind. And we have seen all this approach into the linear, multiple linear, and we have seen the multiple regression, linear regression, and polynomial regression. So we have the independent. That is the 2 point we need to keep in mind. Now, next point is saying to us, what is the aim of the regression? The aim of the regression is to predict the information, something in proper way. So, what is the aim? That is our predict some value. So, that would be what? That would be our aim, or that is our objective or proposed functionality for the this part. So we have the two important variables. Those are the dependent, independent variable, and we can have the multiple independent. But right now we are focusing on one independent and dependent, because on the independent variable, dependent variable will be selected. The values of the dependent variable will be identified. We have the prediction. So what is the purpose of the regression? The purpose of the regression or the aim of the regression will be to predict the something. That's why we are focusing that part. But when talking about the classification, that one you need to keep in mind. When talking about the classification, if I'm writing something here in form of the classification, so what is the objective of the classification information? So far, we have not seen any algorithm. So far, we have not discussed anything which belong to the classification. In the regression, we have seen the linear regression, we have the multiple regression, polynomial regression. The examples we can say. But even talking about the classification, in the classification, we can classify the data based on the. We can write the based on the Boolean values. Okay, based on the Boolean values. That is a summary I am speaking over here, then you can understand based on the Boolean value. And what is a Boolean value? Or Boolean values? Say yes or no, 1 or 0. We can write understand by true or false. So this is the examples by which we can say these are the classification can be done by the on based on the these kind of the values. But in the decision tree, what we need to see? See, in the regression, if we are following the decision tree, so our objective along with the regression, decision objective of the decision tree followed by the regression would be to predict the value, to predict the something. So if I'm making a decision tree, so I'm making a decision tree, then this tree will predict the something that is the objective. So this tree, this decision tree, I'm writing simple way. Decision tree will predict the something from the our information. Okay. But the classification I'm speaking, so tree will be classify the data based on the features. And what is the features? What is the feature? So that is the point we need to keep in mind based on the feature. So information will be classified in the decision tree based on the features. Information in the classification will be classified by the based on the feature. I can write over here based on the feature data will be classified. Data will be classified. That is the point you need to keep in mind while learning the difference between the regression classification under decision tree. That is my point. But you have been observed the important point over here so far. What we have seen in the regression, we will define. So what you need to define? We will define. We will define this important term, that is what is the independent variable and what is the dependent variable. We will define. Who will define? User define. I can write here for understanding purpose. So in the regression, as a user, I will define what is independent variable, what is dependent variable. But in the case of the classification, if feature I'm selecting. So first feature I will select, that is this one. But in the list of the feature, if machine will decide based on this feature, your information will be categorized. Now listen carefully. If or we can say that if machine, or we can say that if the system or machine, we can say here if the system or machine in the classification machine, if the machine and system decide the classification, not if, we can say yes, we can set as true factor, so machine will decide or system will decide. We can also define, but in the case of the good classification of the decision tree, system machine will decide. I can write over here right now, will decide the feature. So user is not required to specify the features over here, but if a user is defined, so first time or first he will or she will decide, the user will decide, but next level, at this next level, we can say that at this next level, at the root, user will decide or user can decide. It's up to you. But if I'm not choosing, if a user is not deciding, no problem. Then at the root, system or the algorithm will decide what is the best attribute or best feature. So here we can say, right, what is the best feature, what is the best feature at the root or at the any level and this point. So if system is deciding this point, so classification information can be classified in simple way. That is the point you need to keep in mind. In the regression, you will always define the independent variable, dependent variable. But in the classification, your information will be classified by the Boolean values. But if you're talking about the Boolean values, we have the some information. So having seen the data set by the system, by the machine, the classification algorithm followed by the decision tree will opt the best feature or best attribute. So dependency on the user will be ended. So that is the point we have over here. So in the decision tree, the classification will choose the in the decision tree, in the classification will choose the best attribute. So the question we have over here, how to choose the best attribute, and that is the point. From this point, we need to understand how to build the decision tree followed by the classification approach. Regression, no need to think about the more thing. We will just call the function. We will use the function. But in the case of the classification, we need to define something. So when you're deciding something to choose the best attribute, and that is to be identified by an algorithm, and that algorithm we will discuss, that is known as the ID3 algorithm. So here we will set the best attribute, best feature followed by the ID3 algorithm. Yes. Now Tell me any doubt from this slide. Yes, tell me any doubt in the slide. You have any doubt, then you can ask me. In the regression, we need to choose the dependent variable, independent variable, but in the classification, we can choose the one feature, but no need to choose because based on the data set, the algorithm is smart and it can directly choose appropriate feature. That is the sense I'm speaking over here. Now tell me any doubt from this slide. You have any query, then you can ask me right now. Yes, tell me.
No doubt, sir.
No
No
doubt, sir.
doubt, sir.
Okay, so the thing I'm speaking is it clear? And the classification we will discuss in simple way by the logistic regression. So that is the point we need to keep in mind. But before that, we need to see the descent tree with the regression with practical. So next class, of course, will be with the practical. But before that, we need to understand what is the purpose of the descent tree with classification. If we are building a descent tree followed by the classification approach, then how we can build? That is the point. Regression, there will be no issue, but in the classification, we have so many issues. And to overcome such issues, such problem, we need to understand step-by-step approaches. So I'm just moving to the my next slide. That is we have over here. Build a descent tree using ID algorithm, ID3 algorithm. So what is ID3? ID3 is nothing. Basically, it is an algorithm of the building a descent tree followed by the classification approaches. So ID3 stands for the iterative dichotomizer 3. That is the version only. So the iterative dichotomizer is an approach or algorithm, and it is the most effective algorithm to build the decision tree. And what is why it is known as the most effective? Because it supports the two important parameters. One is entropy and information gain. So based on these two measurement criteria, our attribute will be selected as a form of the or our feature will be selected as a best feature. So in our data set, suppose we have the n number of the features, but which feature is best, by which we can identify, we can classify. And that is the point we can understand. Just like example, we have the student roll number, student name, student age, student gender, student stream, student branch. So branch, gender, and okay, student age or other kind of the factor. All these are the features by which we can distinguish. But definitely our system, our the addition tree algorithm will choose the appropriate decision or appropriate best attribute or feature. So it could be age, it could be your gender, it could be the branch. So how to identify which is the best feature? And that is to be done by the system only, and that is to be done by the some algorithm, and that algorithm is known as the iterative dichotomizer algorithm. So here we will start to understand iterative dichotomizer algorithm. And keep in mind, to understand this concept, we need to follow the entropy and information gain concept. So I'm explaining this algorithm step by step, then you can understand. And whenever you have a doubt, then you can ask me anytime. I'm speaking step by step, please listen carefully. In ID3 algorithm, what we need to do, we need to follow the its structure. And what is the structure? So let me explain. First step is saying to us, select the best attribute features. Okay, select the best attribute features just like at the top, at this root. So I'm here and at this root, I need to choose the best attribute. So as a user, if I'm choosing, so definitely no problem. So what is the purpose of the defining the my model in, or what is the purpose of training the my model, that is the recently classification? No, the aim of the this approach is saying to us the system will decide the best feature automatically, so there is no involvement of the user. And that is the beauty of the decision tree. So decision tree means a tree representation from the decision, and decision will be taken automatically by based on the features and its various possibilities or possible outcomes. So select the best attributes. After choosing the best attribute, we will decide this is our decision variable and say your age. So if your age is less than 25, then you will go to the left side. If your age is more than 25, then you move to the right side. So what you are defining? On the base of the A's feature, your information to be classified. Now, after classifying such information, what would be the next feature on which the your information to be more categorized? So if I found the student who belong to the less than 25, say example, I'm speaking here, so I'm doing over here. See, the student who belong to the less than 25 years, they will come left side. The student who belong to the more than 25 years or equal to 25 years old, they will come to the right side. From this point, from this point, we can have the other features on which we can categorize, just like the based on the gender. So the student who belong to the male category, they will come on the right left side. The student who belong to the female category, they will come to the right side. So where at each and every level you are classified your information. So you can see observe here, and ID3 algorithm is saying to us that it iterates with dichotomizer 3, that number of the person only. So what you are doing at each and every level, you are doing the iterative process, and based on the features, you are doing the iterative process to decide the which information or what data to be move to the left side or what data to move to the right side. So you need to filter some information based on the your boolean value. And what is a boolean value? That is true, false, or 0 1 value, or we can say yes or no. Because on respectively of that value, you have distinguish your data. And definitely we are making a tree, and that is known as decision tree. Same thing, we can move to the student who belong to the more than 25 years. They can also classify it, or they can also consider as a male and female. So we can put over here. That is the point we need to keep in mind. And after that, in the male and female, so in the male, if I need to distinguish those students who belong to the different states, so I can distinguish. So what I'm doing, I'm again classifying. So it's your problem, it's your requirement, how you are classify your information. So keep in mind, just now come to the point on the algorithm, then you can say select best attribute, assign A as a decision variable for the root node, as you have seen over here. Now for each value of the A, build a descendant of the root. So we are expanding the node, left to left node and right node, and so on. So its process will go on and form the iterative pair. And assign classification label. The word it is written over here, that is a classification. Keep in mind, classification. It means the ID3 algorithm, the decision tree is specially used for the classification. That is my point. As a leaf node. As a leaf node, because after the leaf node, you will not expand more node. And if data is currently classified again, it was coming, now stop. So after classifying, okay, now student belong to this gender, now stop, no issue. And this process will be done in from the iterative process. After getting the iterative process, now finally we got the result, then we can say, or in result in terms of the tree, then we will stop the our process. And that is a thing we know, that is a ID3 algorithm. But the question again is still in your mind, and it should be in your mind. If I'm saying ID3, so keep in mind ID3 is an algorithm which is using the two important concept, that is the entropy and information gain, and based on this parameter, we will select the best attribute, because we are not selecting. It means each and every level, how many levels, how many times you will select feature. So to better idea, system will choose the this feature automatically based on your its two mathematical concept, that is the entropy and information gain. Now, what is entropy and what is information gain? I will tell you with some example. But before that, let me know the status is clear to all. Its example is clear to all. What is mean by the ID3 algorithm and when we need to use ID3 algorithm? Just tell me. Is it clear?
Yes, sir.
So if anyone asks you in any time when ID3 algorithm is applied, ID3 algorithm will be applied where we use the decision tree followed by the classification. And that is the point you need to keep in mind. Now, is it clear?
Repeat once. Repeat once.
Yes, tell me any doubt at any point.
Sir,
Yes, tell me at which point I should explain.
the last one what you said, no.
Which one? Step number fifth or sixth? Which one?
हाँ सर जी, fifth sixth दोनों ही कर लो सर.
See, sixth one is saying to us, if we found this is a node, and this node can be classified in more detail, then you can follow the iterative process to classify your information based on the some features. Just like example of test one, after finding the details, your is more than 25. No problem. You have got the detail. Next feature, you are using the gender. Not you, system will choose, and gender. So based on the gender, your information will be classified. And finally, you found that if your age is 25, you are the male, then maybe based on the other attribute, those could be identified that your what is your hostel number. So what is your boys hostel number on which we can classify your data. So this process will go on till we get the leaf node, and that is not to be possible to expand more. So at that time, this node becomes as a leaf node because now the expandation of this node will not be possible, and that would be our possible outcomes. So that's why it is written over here as iterative over the tree. So this process will go on iterative in form of the iterative process over the tree. So that is my point. Yes, now tell me. Now tell me at this step, right now.
No, sir.
So this algorithm is clear to all because please keep in mind each and every step is necessary. Listen. This step is clear. All these steps are clear in the ID3 algorithm.
Yes, sir.
Okay. So after understanding the algorithmic step, let us understand the working of the decision tree model. Now, what is the working of the decision tree model in practical way, very truly speaking? So you can say we have some data. We have some data. On the data, what you will do, you will train our model. Okay. So before training our model, we need to classify the data into two different parts. One is a training data, and other one is a testing data. This training data will be used to train our model followed by the decision tree. So how we can train the model? Of course, we need the training data. On this data, you will choose the best or attribute selection approach, and that could be identified by the attribute selection measurement that is using the ASM. ASM stands for the attribute selection measurement you have seen over here. And the example of the attribute selection measurement are the information gain or Gini index or Gini ratio, or and that is the point we need to keep in mind. We have the information gain. So in solving our problem, we will use information gain that is sufficient. But to solve this information gain or to gain the value of the information gain parameter, we need to calculate entropy. And without the calculating the entropy, how you can get the information gain? So it means information gain value can be identified by the entropy value. So first we need to calculate the entropy, and then we will calculate the information gain. So information gain is what? That is the best attribute selection parameter by which we will choose, and that is a part of the ID3 algorithm. So with this algorithm we will choose the our algorithm in appropriate way. So ID3 is an algorithm which is required to follow two important parameter. One is what? Entropy, and another one is information gain. So rather than the seeing the other kind of the thing, we will focus on the information gain, and that is sufficient part. Now, what would be the next step? Next step is saying to us in the decision tree class generation part. That is, we will break the data set into the smaller subset based on the what is the parameter, based on the features, based on the features, based on the features. You will classify or you will distribute the data into different level or different ways. So that's why point we have over here. That is what we have. We have the smaller set of the data, and those data is known as the smaller set of the data set. So what you are doing, you have the student data. Your data is divided into two different parts, greater than 25 or more than 25 is, and then again you have the gender classification. Then you are dividing your information based on your at each and every level on the basis of the state or city, or maybe based on the hostel number, or maybe based on the other kind of the string and branch. So what you are doing, you are dividing your data, and this process will go on repeatedly until we get the our possible outcomes in form the leaf node, and that is to be done by the decision tree process. And after training the model, and see, this is a point where we can understand this is the drawback. See, what you are choosing, you are choosing the first attribute selection measurement, and then process will go into from the iterative process. So to train the model, it takes much time for the computation. That was the drawback we have seen, and this is the point where we can say, but this is the concept we need to follow. And after training the model, your model will be evaluated by the some parameters, and those are identified by the accuracy. What is the accuracy of model? After generating the model by the decision tree, then we have the accuracy, we have the precision, we have the recall. So these are the different kind of parameters by which we can identify what would be the accuracy. So point I am speaking here now, this case in the regression, what you will do, you will predict the information. Are you getting correct answer or not? But the classification, we will measure the accuracy. If you classify the data, if you are getting the good accuracy, suppose more than the 90%, so you have classified your data in appropriate way based on the features. But you are having the very bad accuracy, so you can say our data is not classified into the appropriate way. And that is the point. So measurement criteria in this regression will be done by the important point that is known as the MSE. So MSE is what? That is the mean square error by which you can measure the performance of your regression model. In the case of the classification, you will measure the performance of your model by the accuracy, and that is the point you need to keep in mind. So accuracy is what? That is the measurement criteria in the classification, and MSE is the measurement criteria in the regression. So this is what? This is the I can write over here for your betterment measurement criteria. So that is, you can say, in this we have this one, and here we have this. That is the point we need to keep in mind. Okay. And after understanding this point, I'm back to my this diagram. So your model will be evaluated, and then you will see finally if you are getting the good accuracy more than 90%, 80%. So you have classified your data in proper, and that is the point you need to keep. Okay. So now is it clear? This diagram is clear to all? Just tell me, student, any doubt in this diagram? What we have seen, but just we are discussing only. Now tell me, any doubt? Please speak fast. Yes, tell me, any doubt in this diagram?
No, sir. No, sir.
No, sir.
So please, this is the most important slide where I have classified, sorry, I have distinguished the regression and classification in proper way. Regression can be measured by the MSE, that is the mean square error, mean absolute error. We have seen into the linear regression, polynomial regression, and multiple regression. But in case of classification, accuracy is the major performance criteria by which we can measure the performance of the model. And that is the point we need to keep in mind. Okay. So after understanding this point, we need to again back to our ID algorithm, ID3 algorithm. So what is the ID3 algorithm is saying to us? First step in the ID3 algorithm, we are saying we must select the best attribute. But what does it mean? Why we are selecting the best attribute? Why? Because we can classify the data in proper way. So the point here we need to keep in mind in summarized way. There are two important measurement factor on which we can select the best attribute. So just you can move to the right last point directly. There are the two measures are used to decide the best attribute, that is information gain and entropy. But to calculate the information gain, first you need to aware about the entropy. But you don't know the entropy, then how you can calculate the information gain? So from this point, I can explain the first point, that is a entropy. So from this point, we are discussing what is mean by the entropy. So let me explain what is mean by the entropy. Entropy means entropy measures the impurity or uncertainty present of the data. So in the data we have the lots of the data. So first we need to identify the impurity and we can say the uncertainty. So how we can identify? So if you are finding something impurity or uncertainty, and that is to be done by the entropy. So entropy is basically what? It is a measurement factor that determine the impurity or uncertainty in present of the data. So when we calculate the impurity or the uncertainty of data, then we will calculate of the each and every node. We will calculate the each and every node impurity. So each and every level we have the number of the nodes. So n number of the nodes will be measured by the n number of the impurity. So that's say suppose we have the 5 nodes in our tree. So 5 impurities of the each and every node we will get it, and that is a good thing for the our decision tree. So decision tree will support the two important factor in the classification to provide the best attribute. So what we have the two measures by which we can select. First one is entropy, and next one is information gain. Without the entropy, you can't measure the information gain. So first we will calculate the entropy. Without wasting much time, I'm explaining right now entropy. So entropy measures the impurity, and that is the point we have over here. Now, what is the equation by which we can calculate? So entropy you can measure over here, and that is simple fundamental of the mathematics we can written over here. Entropy is equal to negate of the summation of the I equal to 1 to n and pi xi. Why pi xi? I have just updated this equation. Why? Because we have the n number of the dependent variable, independent variable. So on that parameter we need to choose. So x is always what? X is always independent variable, and if we have the multiple, then we will choose. In the case of the independent dependent variable, that would be the part of the regression. But here we are talking about the classification. So here x is what? X is a feature. Okay, and that is based on the feature we will decide the something, and that is to be identified by the node. So here x we can't say here x is not an independent variable. Here x we will see about the features of the or nodes or values on which we will decide something. So that is the point we have over here. So what is the equation? Summation of the I equal to n to n. So if we have the n number of the things, we can say, and p which is probability, and that is the equation we can over here. And to avoid the confusion, I have a simple equation by which you can understand. If we have the s is what the n set of the data, n set of the data. Suppose we have the n set of the data. So S is a set of the some information group, and what is the equations? Summation of the I equal to C. C means the total number of the information we are carrying, and Pi log to Pi. So from this point we can put the value. But how to find all these values? So these equations may get confused. To avoid the confusion, I have written this equation in simple way. And from this point you can understand. Suppose we have a node that is play golf. So there are two possibilities, yes or no. So at the play golf at this node, suppose at this node can be expanded by like this one, yes or no. But before this explanation, let us calculate the impurity of this node, that is this node. So this node is known as the play golf. As I can write the PZ. It can have the value yes in form of the yes or no. So yes, no, yes is value having by the 9, and no is just maintained by the 5 values. So if I need to find the impurity of this node, let us explain once again. If I need to find the value of the impurity of this node, then how can I identify it? Because this node has the decision. If play golf people are ready to play golf, so they will move to the yes side, they will move to the 9. So our sample data that was a 14. 14 is the our sample data, and that is divided into the 9 and 5. Okay, but this 14 is a root node and which contains the number of sample node, and we can say in this case we need to find the impurity. So we need to see how many people are ready to play the golf, that is a 5, and don't play we have the sorry, play was the 9, and 5 is a don't play. If we need to calculate the impurity of this node or entropy, then how we can get? So we can write the entropy 5 comma 9. If you want to write the 9 comma 5, it doesn't mean. And from this point, first we need to write the probability. So instead of the writing the direct value, we can write or simplify our mathematics. We will simplify the our value in form of the probability. So 0.36 is the probability and 0.6 for the probability of the 9. That is the play. So how we are getting it is written over here. You can say the probability of the 9 we can find by the 9 by 14, that is a 0.64, and probability of the 5 by 14 that we can get is the 0.36. So I have written, or I have just written directly either 0.36, 0.64. So we got the probability. So all these are what? These are the probabilities. And we put the probability value in our equations, and then finally we got our value minus 0.36 multiply log to 0.36 and minus 0.64 log to 0.64. So finally we got the value 0.94, and that is a what? That is the impurity of the or entropy value of the this node. That is our first node. That is the root node. So we got our impurity. But suppose we have our objective. We have our objective. What is our objective? If we are getting the entropy value 1, so we will stop our splitting of our node. But here we are getting our entropy. We are getting 0.94. So we can explain our value in more and more detail way or more based on the other features. So our aim should be clarify what would be the minimum entropy. You must decide. But in the system, we are assuming the entropy value should be minimum 1. Finally, we are getting, and we can say it means there is no required to more splitting. But we found that we are not getting the one value, so definitely we will split our value. But here we need to understand how we are getting this value. Okay, tell me any doubt in this calculation? Tell me, any doubt in this calculation?
No doubt, sir.
So how we are getting the each and every value? Is it clear? Please tell me carefully, because this is the most important point where I can design the 2-3 questions into the examinations. That's why I'm saying. I will give you any exercise and you need to calculate the entropy values. So that's why I'm saying. Please tell me.
Yes, sir, it's clear.
It is clear how we are getting the values.
Yes.
Yes, sir.
Any other student who is having doubts, sir, we are not able to understand how we are getting the value, so please let it me know right now. Because when we are getting the information gain, then you must be known about that part. Okay, for
वापिस
you,
बता सर, वापिस बताओ ना ये वाली चीज.
वापस बताना है कैसे निकाली वाली वैल्यू.
हाँ सर.
Okay. I will take an example, then I will tell you. Don't worry. So I'm taking a simple example for your betterment. So I'm just here. I'm just adding some extra. See, yeah. Suppose there is some chance. Okay, so it can rain. So rain is what our node name. Okay, I can give this a node name. The rain. Rain can be or not, maybe or not. So if we are assuming there is some possibility, rain may some possibility be found. That is that. Suppose two people are saying rain may be. So I got the answer 2. And other students are saying, or few people are saying rain may not be. So I can design here if rain is going on, so I got the 2 value. If there is rain not be, so I got the value that is 3. No. So I've classified by information yes or no. So total number of we have over here, that is 2 plus 3, we can got the 5. Total number of the values at the root level or sample we have over here, that is a 5. So sample at the 2 root levels, I can write the sample at the root level, that is the first remaining sample, that is we have the 5 at the root. I can write like this one at the root. Okay. Now this point is clear? Yes, tell me, is it clear?
Yes, sir.
Okay. So what is our question? Our question is to entropy of the root level, that is rain. Okay. So rain may or not, we need to check. This is our entropy we need to get. So that is our question we need to solve. So how we are getting? So I'm explaining one by one. So what is the positive? Two things we have over yes and no. So first, rain, I can write like in the mathematical way, rain, comma yes. So what is the probability when the rain can be? So probability of the rain can be that is yes, people, I got that is answer. So 2 by 5, can I write like this one? Just tell me, can I write 2 by 5? That is the probability of the rain maybe.
Yes, yes, sir.
Okay, and when there is some
Yes.
probability, when the probability the rain may not be, so I can write like this one, that is a 3 by 5. What is the value of this one? 2 by 5 and 3 by 5. Can anyone tell me? 0.1%.
0.4, 0.6.
Okay, 0.4 and 0.6. Good. So this is the value I got it from the probability value. Now, any doubt over here? Tell me, is it clear?
Yes, sir.
Okay. So if
Yes.
I'm right, okay, good. So if I'm calculating the entropy of the rain, where I'm discussing about the first node, that is the rain. Okay. Then that could be identified by the, what is the probability? 0.4 multiply log 2 0.4, and that value will be in negate. And then what is the next value we are having here? That is a 0.6. So according to the next value, we will do again same thing, 0.6 multiplied by the log 2 0.6. I can write like this one. So this is what? This is the entropy of the rain at this node, where we have the found value. Yes, 2 people are going, and no, 3 people are going. And from this point again, you will explain your based on the features, maybe rain, maybe so rain, maybe all the kind of the feature based on the other kind of the feature. Okay, so this information will be flown. So again, at this node, again we will get the entropy. Again we will also get the some entropy at this point also. So total number of nodes we have 1 2 3. So 3 here we have, again we are adding this point. So total we have the 5 node right now. So in this 5 nodes we will get the entropy of the 5 nodes. Okay, that is the point. But if the manually we can do, but if we have the thousands or we have the long very long descent tree where we have the thousand information, so it will not be easy by the human. So that's why machine is required. So here we are getting the entropy of rain. I'm just packing over here. So you can put the value, what the value we are getting. So on that value, we can write the answer. So we will get the value, that is the entropy. Okay. So can anyone tell me what is the value we are getting? Can anyone tell me what is the value of the 0.4 into log 2 4? Can anyone tell me what is the value? Yes, tell me what is the value of the log 2 0.4? Yes, don't tell me. You can use a calculator.
So minus 1.32.
Log 2, I'm talking about the log 2 0.4. Okay, so minus 1.32. Okay, minus 1.32. Okay, and what is the value of the 0.6? Can you tell me?
Minus
Minus
0.73.
0.73.
Minus
73.
0.73. Now use your calculator to tell me. Okay, so finally all these values will be in positive. Okay, so no doubt. So what is the value we are getting over here? Multiply by the 0.4 into the 1.32. Can you tell me? Just tell me.
0.528.
0.528. Okay, and if I am using this value, so now tell me what is the value of this one? 0.6 into 0.73 according to you. Just tell me what is the value. Just tell me.
0.438.
0.438. Okay, after adding these values, can you tell me what is the value we are getting? So we are getting the approximate value 0.966. Okay. Now keep in mind entropy value should be less than 1. If you are getting the entropy value greater than 1, so it means you are doing some calculation mistakes. That is the point you need to keep in mind. So our objective should be entropy value should be equal to the 1, or but it should not be greater than, it should not be greater than 1. If you're getting less than 1 or equal to 1, so it's okay. But if you're getting the 1, so we will stop the bifurcation, or we can say its expansion of the node. But here we are getting the value 0.66. It means what we need to do, we need to, here we can say we need to split. We need to split. We need to split. Okay. Now that is point is clear. So if we are getting the entropy, it means there is some impurity. So there is some impurity, and with this point we can say we need to expand our node based on the some other features. And who will decide the based features? That is information gain as a factor, and that is a machine dependent. So but what is how we are getting the entropy? That is I have explained over here. Now is it clear to right now? We need to split our node based on the other features when we are getting the entropy value less than 1. That is the point. Now is it clear? Just tell me, speak fast. Please speak fast.
What is
Yes,
the
sir.
maximum entropy?
Maximum entropy value will be 1. If you are getting the more than 1, it means you are doing some mistakes in the calculation. So when we get the entropy value 1, that means we our system does not have the, or the particular node does not have the impurity. So we will stop its expansion. It means final we got our value. So at the leaf node always represent the 1 entropy value. That is the point. Just tell me, speak fast.
Yes,
This
sir.
point is clear. This point is clear.
Yes, sir.
Okay. So after understanding this point, I have some example over here. So now in this example, what we have, rather than explaining this example in much more detail, just I am focusing on the simple example here. That is how to get the information gain. But before information gain, just let me explain what is mean by the information gain. And it is a better idea to explain the same example, then you can understand in very manner like this one. So this example is very long example. So I have the calculated value. Okay, so here you no need to worry about the search part. So I'm explaining this example. Here we have the credit score and we have the liabilities. So liabilities and the credit score. So we have to classify the data based on the normal liabilities. We have classified by the high and normal, and credit score can be classified by the it's excellent and good, or we can say poor. So that is the point we have over here. So from you can say the normal, we have the normal liability and excellent, good and poor. So we have the total values over here. So total C1 representing that, and to 3 represent that. We have the excellent credit rating when we have the liabilities normal, and we have the liabilities high, then the credit rating will be the excellent. Same thing, we need to go for that part. So we must focus our information based on the only the normal, high, and excellent, poor, and good. From this point, what first you need to calculate? First, you need to calculate the liabilities, and after calculating the liabilities, entropy of the liabilities, then you can measure the credit. But here you can see, but truly speaking, you need to understand the first problem. So liability is the factor that is can be, see, this is the point we need to understand. In the decision tree, there's some example which describe that regression and classification simultaneously. So in this example, we can understand on the based on the liabilities, your credit rating will be decided. So what is here over here? We have the independent variable, dependent variable. So here, first you need to understand the thing. This program, problem is having the regression problem as well as the classification problem. But we will focus that the first part, that is the classification, then regression can be done by automatically. But let us understand what is the independent variable, dependent variable. So prediction can be done later on, but let me understand how to classify the data. So when we have any problem which is compromising the both approach, regression and classification, so first we will do the classification and then we will go for the prediction. So rather than time, so let us understand liabilities values define the credit score. So credit score is what? Dependent variable, dependent variable. See, so liabilities of the what is the credit score you have, it doesn't mean. But liabilities can be identified by the credit score. So we can say that could be dependent variable. That could be dependent variable, and credit score will be the independent variable. What is the credit score you have? It doesn't mean, but what is the liability you have? That is the point we need to keep in mind. So if you are measuring the another factor like what is the liability and on basis of your credit score, so you will measure that factor later on. But from this point, first we need to identify, or first we need to classify the problem, and from that point we build our model. So first we build the first we build the tree, pulling by the classification, then we will predict. So prediction always done by the letter after the classification. So when you have any problem following by the classification or a regression or classification, then first you need to do classification, and that is the point. Say a simple example: if I had to assume the how many students belong to such class, so first what I will do, I will classify the data, and then after the classify the data, I can easily predict the information. So classification would be the first step. Okay, but here we need to understand what is the entropy of the such value we are getting. So first we will calculate the liabilities entropy. So first here we are getting the liabilities of the entropy. Why? If we are getting, then we can say if we are getting one, so we can say now what is the liability. So this point is determining that is the liabilities having the one entropy. So no expansion of the liabilities variable is required. So now what is the next factor, that is independent variable we have over here? On that we need to expand our information. So we have the some information based on the its classification part, that is excellent. Instead of the excellent or good or poor, suppose we have the one value, it's okay. But here it is found about that credit rating was also classified. Then after getting the liabilities and its other factor, we found that we are getting the one. So it means we will not split our data of the liabilities, but we will split the credit score based on the liabilities. So that is the point we need to keep in mind. Based on the liabilities, we will expand our information, that is the credit score, and at the time we need to calculate the our entropy respectively to the liabilities of the credit score. So credit score or credit rating entropy will be calculated respectively to the liabilities, and that is the point we need to keep in mind. First we are calculating the liability. So it's normal for the normal data, for the normal information we got. So what is the value of the normal? That is the total. We have the see, 7. Okay, so 7 divided by 3 by 7 and 1 by 7. So each and everything you have over here now see 7 by 14 and 7 by 14 we are getting. So we are getting each and everything properly. So liabilities, what is the total liabilities we are getting? We are getting the total liabilities 7. Okay, and what is the total high liabilities? 7. So definitely what would be the 7 by 14? 7 by 14. So there will be no issue, because here we are getting the total liabilities. Here this will respectively this one. So there will be no issue. But individually we need to calculate and along with the credit rating. So we will see. So first we are checking this part. Is it possible to or not? So after solving this problem, we got the one, and that defined our target variable is 1. So at the maximum disorder to the even split between the its normal and high. Now first we are dividing all the information, but before dividing the information, we have used the final values, that is 7. So after this point we got that is the 1. So now next step is saying to us, so there's no liabilities will be expanded, but it has its classification based on normal and high. So based on the normal high, we will classify their data. So how we are deciding? Rather than theoretically, we have this point. So we are not expanding the liabilities more. We are expanding the credit rating based on the excellent and good. So what is the excellent? Just let me explain this part. See, total number of the excellent values under the liabilities we have over here. Total we have the 4. So see, only see this point. So I'm explaining this point. Then other point you can understand in simple way. Total we have the 4. And what is the normal case we have? So that is a 3 by 4. So this value is to be generated by for the normal, and that is the point. And next we have the high. So this value to be generated by for the high. And what is this for? We are getting the value respectively the excellent credit rating. So we are measuring the liabilities respectively to the excellent credit rating. So this is the value we are getting. Same thing we will go for the good. Next thing, same thing we will go to the poor. And after getting this value, we have the three different credit rating liabilities with respect to credit score values of the entropy based on the or with respect to the liabilities. That is the liabilities oblique CR. So we got the each and every value. And after getting this value, we have an important term that is a weighted average. This weighted average is saying to us after calculating each and everything over here, first you need to get the weighted average. But how we can get the weighted average? It is very simple formula. No equations, not of equations required over here. Simple. You need to say in excellent, what is the total we have? That is a total. We have the total excellent, good, and poor is having the value total 14. From this 14, what is the total value of the excellent? That is 4. And what is the value of the its entropy value? That is a 0.81. So we will write over here like 4 divided by 14 multiply 0.811. For the good, we need to write the its 6 value. 6 is the total of the good of the all the credit rating score with respect to liability. 6 divided by 14 multiply by the 0.918. So that's value we have over here. Next value we have the 4 by 14, that is 0. So we will try to do over here. So that will be 0. And finally we will add these two values. We will got the 0.625. And that is the entropy with respectively entropy of the liabilities with respectively to the credit rating. Why the long computation is required? Where we are, whenever we are exploiting our information, we are splitting our information in form the various form. We have the one way division, so we can do in simple way. But when we have the long and more classification at each and every level, then we need to calculate the entropy at each and every level properly. So this is the entropy we are getting only the liabilities with respect to the yeah, that is a credit score or credit rating. But this is only the point which describes me. And to avoid the such confusion, I have a simple thing by which you can understand. So I'm just going back to the my other example. This is my point. In this classification, I'm explaining. Just let me explain. Let me know. The status is clear. This point is clear. How we are getting? First, tell me. Just because it is a kind of the example where we have the two-way classification. In the row side, we have the classification, and column wise, we have the classification. So that's why each and every, respectively, each and every value we need to do. Now tell me. In this example, how we are getting? Just tell me. Just tell me here, any doubt?
No doubt, sir.
Okay, so for your more clarification, I have simple example, then you can understand. See, this example is visible to all. First, tell me, this example is visible to all with the image. Just tell me, this example is visible. Tell me.
Yes, sir.
Okay, so the point you can understand the entropy concept. How we are getting entropy, is it clear? So after understanding this point, yeah, at the root we have the total number of samples 30, and this sample is divided into the two important points based on the features. So we have over here the we have the over here. Just give me that 14 and 16. So our information is divided into the two different parts, following by the some parameter 14 and 16. At each variable we got the our entropy value. So if we need to get the entropy at root node, that is parent node, so how we can get it? So this is the equations. 14 divided by 30 into log 2 14. So why we are doing? That is based on the one value. On the other value on which you have filtered your information, that is the 16. 16 divided by 30 into log 2, 16 divided by 30. So you are getting the value 0.996. Okay, this is your entropy of the parent. After getting this value, at child you have this value that belong to the 16. Number of sample, total number of sample here we have 16. Here total number of sample we have the 14. And here total number of sample was the 30. Here you can more divide as according to your need. So what I can say, we can have the different things. So there will be no issue. But here we have found that your information is total number of sample was a 30. But at a child, we have divided our information into the form of the 14 and 16. So instead of the doing so thing, we found that our information is not classified as 16 14 if our information is divided by the 17 and 30. So at this point, you need to calculate, you need to say your this 17 and this node which is having the total number 17 is divided into two different parts, that is a 13 and 4. Now 13 and 4. So what you are doing? You need to calculate the entropy, and after getting the entropy of this node, at this node again you will get the entropy. So you are getting the entropy of the child node, that is the 13. So because this is divided by the 13 and 4, so you will get the entropy at this level. So that is the 13 divided by 17 into log 2, 13 divided by 17 minus 4 divided by 17. You can write this equation. इस equation को हम कैसे भी लिखेंगे कोई फर्क नहीं पड़ना. So minus 4 divided by 17 into log 2, 4 divided by 17. So we got the entropy value over here, that is a 0.787. So we have divided this part into 2 parts. So before splitting, what we need to calculate the entropy. So I'm explaining this diagram in simple color, different color, then you can understand. See. So I'm just taking this example in different color, then you can understand in simple. See, first what we are doing, we are having a total number of sample 30 over here, and we are having this information we can divide like the 14 and 16. So first we need to calculate its entropy. Okay, so after getting its entropy value like 0.996. So what your next activity is saying to that it is not equal to 1. So we need to split our information into the two different parts and followed by the 14 16. But here what the image is saying to us, it is divided into the two different parts. One is a 70 and other one is 30. Now the question is saying to us, before splitting this part, let us check or calculate its entropy. Maybe if we are getting the entropy value 1, then we will stop its splitting part. Let us check the splitting of this part. If we found that total number of sample we have the 17 over here, and then this contain the information to two different parts that can be identified by the 13 and 4. So before splitting, let us check this part. Let us check parts of the entropy. So how we are getting the entropy? 13 divided by 17 log to 17 minus this one. So we are getting the its entropy value 0.787. Now at the other end, if we have the 13 is the right side node, which is saying to us it can have the values following by the into two different samples. One is a 2 and 1 and 12. If we are getting the its entropy value, that is coming over here 0.39. You can see over here. We found that it is not equal to 1 and it is also not equal to 1. So what we need to do, we need to split our information into two different ways. So here we are dividing, here we are splitting. Okay, so here we are dividing our information based on the number of samples 17, and based on the different kind of the values that is to be held by, that could be identified as 30, and we have the over here 4. Same thing we will go for over here, that can be identified by the its value 1 and 12. So it can be observed over here, there is only the one value, there is only one value here. So here no splitting is possible. Why no splitting is possible? Why? Because there is only one value, and that would be identified only the leaf node. No splitting because of the 1. So here no splitting is possible. But in the case of 12 or 4 or 13, we need to calculate its possible sample, that is we have the 13. Suppose 13 can also have the different kind of two values. So we will see how many belong to value belong to the this value and this value. And this is a different kind of thing I'm just taking. Suppose 13 we have the 6 value that belong to the x value and 7 value belong to the y value, y kind of the value. So we are getting the its entropy. If we are getting the its entropy value is equal to 1, then it's okay. Else we found that its entropy value is not equal to the 1, so then we will start its splitting. And that is the point, define the entropy part. But the next question is saying towards how to define the its information gain. So you can say over here just this is the point. So at each and every level after entropy getting, at each and every node at each and every level you need to calculate the weighted average, and that is an important part which describe the is it required to splitting a node. So now finally we are getting the 0.7. So now we are getting the 0.7 87, that is the entropy of the this left side node. Right side node is having the entropy value of the 0.391. But from this point we can't say we can't split we are splitting or not. Before that we have to calculate the its weighted average. So how we can get the weighted average? So here we have the formula. Total number of sample which is considered by the left side, that is the 70. Okay, and its parents was the 30. So each and everything we need to keep in mind. So that is the point we need to keep in mind. Its child having its entropy value, this value, and its parents also having its value 30, and multiplied by the its entropy value, that is 0.78, and 13 divided by the 30 into 0.391. So we need to calculate the weighted average of this node, weighted average of this node by the child. Okay, by the children node, we need to calculate the weighted average. So value which is used by the node that is taken from the children entropy value. So that's why we are using its entropy value. So that is the point. We have calculated the entropy. But now what is the information gain? Information gain is nothing which is the most significant measurement criteria, because you found the entropy, that is the impurities. After getting the impurity, what is the parameter by which we can say we should go for the calculation? No. So information gain is the most important significant which is used to build the density and decide the how much information you are getting. And there's nothing idea, the simple idea what we have, we need to just use a simple formula like this one. Don't waste your time. It is better idea to what is the value of your parents node you are having, and you need to just subtract that value, and you are getting value equal to 0, then no need to explanation is required. That is true fact. And if getting the value is more than 1 0 more than 0 value, definitely you need to explanation. So information gain of the anything is saying to us, if you are like this one example, you can say on this example. Now see, what is the information gain? What is the parents information? What is the parents entropy we are getting? That is 0.9 this one. So and parent entropy minus weighted average of the children, we need to subtract. If we are getting the 0.38, so then we need to split. And if we are getting the 0, then we will not split. That is only the idea. So what is the formula of the information gain? Information formula is saying to us entropy parents minus average entropy children. So what is the average entropy children you are getting? You are getting the average entropy children for the parents by which, that is you are used to like this one, this one, this is the. So average entropy children, just I can mark over here average entropy children, you can get it like this here, 70 divided by 30, 35 we are taking because we are getting the and information gain of the parents. So here we are getting the information gain of the parents. I can write over here information gain of the parent. Okay, so before getting this point, we need to get the entropy. Now entropy of the parents we are writing over here, and average entropy children we are getting by this equations. So this value we need to subtract that value and we are getting 0.3. If we are getting the 0, suppose we are getting the 0, then no splitting is required. No split. Because after getting 0, what is the information in 0? So no splitting is required. So that is the point we need to keep in mind before splitting. But this is the entire calculation is to be done by the our classification time and which is used by the feature. This is the only simple idea. Yes, tell me. At this point, you are having a note. Please, you can ask me.